Hi, welcome to Unit 8, Day 2 on concentrations. This is Part 2, Diluting Solutions. So in the previous examples in Part 1, we learned how to make a solution and calculate its concentration. And the solutions were made by dissolving a solid in water. Now, this worked for the examples that we've seen previously because they were metal hydroxide bases. And metal hydroxide bases are ionic compounds. And we know one of the properties of ionic compounds is that they're solids. So, of course, if you have a solid, you can easily weigh out its mass and then use a volumetric flask to create a solution of a certain volume. And so here are some examples of metal hydroxide bases. You can see that they're all solids. But what about in the case of acids or amines, which are not solids? And usually they're found in solution, but if you were to get pure hydrochloric acid, that's not in solution, it's actually a gas. And then and in this gaseous form is actually doesn't really act as an acid. It has to be in solution to act as an acid. So what do we do in this case? How do we determine their concentrations? So how do we determine the concentrations of an acid or an amine? So in this case, what we do is we use dilutions to do it. Because usually what happens is if you purchase these chemicals from a company, they're usually in really concentrated solution and you want to dilute them. And then once you dilute them to the concentration that you want, you'd have to actually calculate the concentration that you get. So we're going to learn how we can dilute solutions. What's the proper way to do it? All right, so in this video, we start off with a stock solution that, if you saw at the very beginning, had a concentration of 0.250 molar. And then the next thing you do is you use what's called a pipette to suck up a certain volume. This pipette is a 10 milliliter pipette, and you see that marker there, once you reach that marker, the liquid level reaches that marker, you have 10 milliliters of what's called your stock solution. So that 0.250 molar solution that was in the Erlenmeyer flask that you started off with, that's your stock. And you're going to dilute 10 milliliters of that. All right, so you've got your 10 milliliters of your stock solution. Then what you're going to do is you're going to take the amount that you have and you're going to put it in your volumetric flask of the volume of the solution that you want to make. Now, one thing that's important to note about these pipettes, you don't have to rinse them clean because they're actually also calibrated and designed. The amount that is delivered from the pipette is equal to the 10 milliliters. All right, once you have that 10 milliliters of your stock solution, now you're going to dilute it by adding water. And then the same thing that you did before, you would make sure you reach to the volumetric flask marker. So let's go over that together. When you're making a dilute solution, the first thing you're going to start with is your stock solution. It's your concentrated solution that's used to make dilute solutions. And here we have 100 milliliters of our stock solution. Then the other thing you need is a pipette to remove a specific volume of the stock solution. In this case, we'll use a 10 milliliter pipette. And then finally, you're going to need an empty 250 milliliter or whatever size volumetric flask you like. And you're going to use that flask to put your stock solution in and dilute it. So let's look at the process. We have our 0.20 molar stock solution. And what we're going to do is we're going to pipette out 10 milliliters of our stock solution. Then we're going to take our 10 milliliter stock solution and put it into our empty 250 milliliter graduated cylinder. Volumetric flask. Then once we've done that, we're going to add enough water to dilute it to the volumetric mark there. And then we've made our dilute solution. So how do you calculate the concentration of the dilute solution? So you notice that when we started, we used 10 milliliters of our 0.02 molar stock solution. What we need to do is we need to convert from the molarity of our stock solution to the moles of stock solution. Then once we have that, we can convert from the moles of the stock solution, our concentrated solution, to the moles of the dilute solution. Now, these two moles are equal. And the reason why they're equal is because the number of whatever is in your stock solution, let's say you have a stock solution of sodium chloride, right? If you pipette out 10 milliliters of the stock solution, and in that 10 milliliters you have, let's say 100 molecules, those 100 molecules are going to go into your dilute solution. And only thing you're adding to the dilute solution to dilute it is water. You're not adding the molecules of your solute. So the molecules of the solute will be the same, so the moles of the solute will be the same. So that's all to say that the moles of the stock solution is equal to the moles of the dilute solution. Their moles are the same, but their concentrations are not. Because in the case of the dilute solution, you would have added more water and made it less concentrated. So your next step then is to go from the moles of the dilute solution to the molarity of the dilute solution. And we know the volume of our dilute solution, so all we need is the molarity. So how does this process work? We use what's called the M1V1 equals M2V2. That should say M2V2. So M1V1 equals M2V2. I just made that correction. And this equation allows us, if we're given the molarity of and the volume of our stock solution, so our M1 and V1, and we know the volume of our dilute solution, our V2, we can plug those numbers in to solve for M2. So what exactly does that look like? So in this case, we would take the M1 and V1, we plug it in, so 0.02 molar and 10 milliliters, we plug that in on the left side. And on the right side, we have M2, which is what we're trying to find, and then our volume, 250 milliliters. We do our math to solve for M2, and we get M2 is equal to 0.0080 molar. Now, one thing that's important to note here, unlike in part 1 where we had to convert the volume to liter because we were calculating molarity, for the M1 V1 equals M2 V2, you don't need to convert the volumes to liters. As long as your volumes are in the same units, if they're both in milliliters or both in liters, that's fine because that conversion sort of cancels out. All right, so overall for this problem, we would say that the stock solution, which is what we started with, the more concentrated solution, was diluted from 0.20 molars to 0.00080 molar. All right, why don't you try this CFU using the M1 V1 equals M2 V2. So a scientist takes 25 milliliters of a stock solution and dilutes it to 500 milliliters. What is the concentration of the dilute solution? And just so you know, this is a solution of HCl hydrochloric acid. So that's the solution that you're making. So you're going to use the M1V1. Oops, sorry about that. You're going to use the M1V1 equals M2V2 to calculate the concentration of the diluted solution, and then use the pH equation to solve for the pH. Pause the video now. When you press play again, the answer will be revealed. All right, so here's our work for that. So our initial molarity is 1.0 molar stock solution, and we use a volume of 25 milliliters. So we multiply those together on the left side. Then on the right side, we have the molarity of the dilute solution, which we're trying to find, multiplied by its volume, which is 500 milliliters. Then we divide both sides by 500 milliliters to solve for the molarity of the dilute solution, which is 0.050 molar. The next step is to calculate the pH. Now the pH is equal to negative log concentration of H+. We found the concentration of HCl over here. But remember, for an acid, the concentration of H+ will be equivalent to the concentration of the acid. They're going to be the same things. So you just take this number and plug it in, and that's how you get the pH. All right, so that is it for this video. I hope you found it helpful. There are some examples and practice problems for you to do, and then a short exit ticket this time. All right, have a quality day.